is solving exponential equations. Type 1 is equations written in the same base. This is all we're going to do for now, because if they're not written in the same base, well, we'll kind of look at it today, how you can punch into your calculator. But if they want you to solve them and they're not the same base algebraically, you're going to have to use logs. So it's only going to come in next unit. So for this whole unit, they're going to have to be the same base, or you're going to have to be allowed to punch in your calculator. Okay? So an exponential equation is one that the variable, typically x, is in the exponent. Exponential. Some exponential equations can be solved by writing the powers on either side of the equation with the same base. You guys kind of did this. Well, a lot of people did it in grade 11 when you guys did sequences and series and you were solving geometric and you had to get common bases. Most teachers taught it very, very simplistically. This can only be done once the power is isolated. If this cannot be done, a skill we learn later in the unit will be used if you can't isolate it. So let's look at this one. The steps: isolate the power. Write each side of the equation with the same power. Equate the exponents and solve the exponential for the variable. The equation for the variable, sorry. So 2 and 8. If I said this to you as an aside, 2 to the x equals 2 to the 3. What would you tell me x would have to equal in order for that to be true? 3. You're like, that's stupid. Of course it would be 3. So that's why when we get something to a common base, we can equate the exponents. It means that we can take these exponents out and I can set them equal to each other. People are like, I just cancel off the bases. No, you're not actually canceling off the bases. You're just setting the exponents equal to each other because it makes sense, right? If they're the same bases and they equal something, then their exponents have to equal the same. So 2 to the x minus 1 equals 8. 8 I can make be what? 2 to the... You get really good at these. No. 2 to the 2 is 4. 2 to the 3 is 8. You'll get good at these by practice. 2 to the x minus 1 equals 2 to the 3. Now, in order for this to be true, what can I say then? It's not 4. 2 to the 4 is 16. What? Oh, you're telling me the answer. I thought you're trying to tell me that this is 4, and I'm like, that's 16. Okay, mister, I'm getting ahead of myself. I didn't know that. Yes, it is 4. X minus 1 equals 3. X equals 4, because you move the 1 over. Or you could spot... Abu? Or you could spot and say, hey, this must be 4, because that'd be 3. They're not obviously that easy, so learn the proper way to do it. All right. Then you can check them. Okay, 2 to the 4 minus 1 is 3. 2 to the 3 is 8. Yay, we're done. Woohoo, we got it right. Okay. 9 to the x minus 1 equals 27 to the x. What base can I make them both be? Remember, it's not multiplying. So some people are like, well, 3 times 3 is 9, and 3 times 9 is 27, so I can make them both be 3. No, it's like 2 to the 2 to the exponent 2 is 4, or 3 to the exponent 2 is 9, right? So what base could I make them both be where I could raise them to a power that they'd have the same base? 3. I was going to say starts with a T, rhymes with 3. 3, yes, good job. So 9 is 3 squared, right? Now, I always write my exponents in brackets, and I would suggest you do as well. So you remember to distribute into them, because that is the common error. 27 is 3 to the what? 3 to the 3. Everyone should be writing, because you need notes. I don't know why else you would want to write them down, but that's a good enough reason. Okay, so do you see if you forget to write the brackets out, some people might just write 2x minus 1, which is actually wrong. You have to remember to distribute that 2 in. That's why I write this in brackets. So it's going to be 3 to the 2x minus 2 equals 3 to the 3x. Now when I have the same base, I can do what? This is base 3, and this is base 3. Then this must equal that, right? Just the same thing as this must equal that. So 2x minus 2 equals 3x. I'm going to subtract 2x over. And then I'm going to get negative 2 equals x. Done. And I could check it. 9 to the negative 2 minus 1 is 9 to the negative 3. 9 to the negative 3 is, I don't remember. 27 to the negative 2, they actually equal, but I just can't remember what they are. 9 to the negative 3 is 1 over 729. And 27 to the negative 2, because I'm just filling it in for x, should be the same. So you know you're right. And you should always know if you're right when you're walking away from these questions. Okay, obviously it's not going to stay that nice because it doesn't. But it doesn't get like ridiculously hard by any means, okay? 16 and a half, that doesn't look like fun and it doesn't look like it's something nice to be. So would I either make the 16 to be in a fraction or I make the half to be out of a fraction? Remember, how can I get a half to become 2 over 1? Raise it to the negative 1. So I'm going to go 16 equals 2, because it'd be 2 over 1 when it flips to the negative 1. Bracket x plus 4. Can I make 16 be base 2? Yes. Always make them be the smaller base. Don't try and make 2 be 16. Okay? You're always making them be smaller bases, smaller bases. So 16 is 2 to the 4. It's true. And then here we'll get 2 to the negative 1x to the negative 4. Or minus 4, I mean. Now we have the same base. So if this base equals this base, then this exponent must equal that one, correct? So I'm going to get 4 equals negative 1x minus 4. Add the 4. I don't know why I canceled those. 8 equals negative x. Is negative x okay to be an answer? No. So we have to divide by negative 1. So x actually equals negative 8. So 16 equals a half to the negative 8 plus 4. So a half to the negative 4. A half to the negative 4 is like 2 to the positive 4. 2 to the positive 4 is 16. So you know you're right. D. 5 and 2. Huge hint. Something is wrong. I can't make 5 be 2 and I can't make 2 be 5. Do you know where the common error happens right off the bat? 5 times 2 is 10. 10 to the x. You can't do that. The only thing that is to the power of x right now is this 2. It is to the power of x. I can't make the 5 join it and make it be a 10. If you're someone who would have done that, write yourself a little side note with a star, say don't do that. Because that means that you will probably do that. So stop yourself. Star, star, star. Do not put these two together. They cannot be together. This one has an exponent. This one has an exponent 1, right? You can't put them together. However, I can divide by 5. I can divide that value over. And so I get 2 to the x equals 8. Now what could I do? So what base can I make 2 and 8 be? 2. Yeah. These at first are a little bit hard for your brain to wrap around, but eventually you'll just start spotting them out quickly. So 2 to the x equals 8 is 2 to the power of 3. Because 2 times 2 times 2 is 8. And so x equals 3. Then we could check it. 5 times 2 to the 3 equals 40. This is the check. 5 times 8 equals 40. 40 equals 40. This one, people sit and stare or change it to a log instantly. You can't change it to a log now, so if I gave this to you, you couldn't. So we have to try and come up with a way that we can make them be the same base. This is a little tool in your toolbox you need to remember. So I have a little star here. Because everyone forgets how to do this. They just forget it. They forget that it's an option. I can't make 6 be 1 in any way. I don't know how that would be possible. I can't do it. Can I make the 1 be a 6? What is it? 6 to the what is 1? 0. Everyone forgets that. Remember anything, so 6 to the 0 equals 1. I can raise anything to the exponent 0 and make it 1. So if ever you have a 1, you can make a common base always. You just raise whatever the heck the other base is to the 0. So I'm going to have 6 to the 2x minus 3 equals 6 to the 0. And now I can just set them equal. It's a very easy question. It's also a very easy question to forget you can do that, right? So you get 2x minus 3 equals 0. Add the 3. 2x equals 3. Divide by 2. X equals 1.5 or 3 halves. I also put those cumulative reviews online in Google Classroom, and I'm going to put the answers up this weekend, the worked out answers to them. Okay, the more advanced ones. So those are the basic ones. These are the more advanced. They're not terrible by any means. There's just one extra little step. Okay? So that last one we had looked kind of like this, right? Not the last one, sorry, the second last one. But it had a 5, and there was no way I could make a 5 be a 2, so there was something like, I need to do something in order to get that to work, right? Because I can't make a 5 be a 2. But if I look at this one, I have a 2, a 4, and a 32. I can make them all be base 2. So let's do that first, okay? So the other ones, we'd always have something equals something, and then we just set our exponents and we'd be done once we got common base. Or we divided the 5 over and we still had something equal something. But this time we have something equals something times something. So we're going to make them all be common base. So I'm going to get 2 to the x minus 3. 4 is 2 to the what? 2 to the 2. And 32 is 2 to the 5. So I'm going to get 2 to the x minus 3 equals 2 to the 2 still, times 2 to the 5x. This is why we went through those rules on the first day. So many of you will tell me that this is 2 to the 10x. It's not. What happens when you have 2 bases and 2 exponents and you multiply them? What do you do with those exponents? You add them. So if you would have multiplied them, leave yourself a little note, star, 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 that says, don't add them. Look at this. I'm getting them. Like so many calculators, so little time. Thank you. I figured because you're the child of the Royce. See? I figured I'm good at this. He blood redded them, so we know they're his. Perfect. Oh, that's on recording. Good times. Okay, so 2 to the x minus 3 equals 2 to the 2 plus 5x. Now we have the same base, and now we can write our exponents together. So it's just that extra step where we had to add those two. You know what? Everyone's really good when this one here has to be broken down into a base, and then they add them. Everyone's really good at that. Everyone's really bad at the next one, because this is 3 to the 1. Everyone forgets the 1. And I'll show you that in a second. So you get x minus 3 equals 2 plus 5x. Do you know what's scary? Is how long people sit here and decide which one they should move, which x. They're just like, I don't know which x. Don't. If you're spending more than 33 seconds, decide. That's even too much. If you're spending more than 4 seconds deciding which x to move, just move one. Just pick one and move it. So I'm going to move the x. This one. I'm going to move it because I'm a rebel, and I just picked it and moved it. See? It still works. If I move that one, it still works. People stare at this for hours. Please don't be that person. So we get negative 3 equals 2 plus 4x. And then people are better once they have like not 2x's and two numbers. So now minus 2. And I get negative 5 equals 4x. Divide by 4. And x equals negative 5 over 4. I want you guys to try number 2. Remember, I'll give you a hint. You can make these all be base 3 somehow. Remember, 1/9 can become 9 if you raise it to the negative 1. You can make them all be base 3. My other hint is, what does this 3 have as an exponent? 1. So many people put 0. It doesn't have a 0. Anything to the exponent 0 is 1. So this has an exponent 1. So on these questions, before I even attempt the question, I instantly put a 1 on that number so that I remember to add a 1, because everyone adds a 0, and trust me, that answer will be there because that is more often picked than this one. Okay, so try this one out. So this one here, just raised to the negative 1, distributed it. This one I raised to the power 4 because that's what 81 is. So you're going to get 8x plus 4. You have to remember to distribute it. Then I raised this as 3 squared to the negative x minus 1. And then I put these together by adding them, which everyone forgets that 1. Do you see how they could easily forget that 1? So you get 8x plus 5. Distribute into 2, negative 2x minus 2. Negative 2x minus 2 equals 8x plus 5. Add the 2. X, so you get 10x, negative 2 plus 5. Subtract the 5, you get negative 7, divided by 10. Number 3, you have the square root of 8. We have to write that as an exponent. What's the square root of 8 as an exponent? 8 to the half. Remember? You bring the 2 underneath. So it's going to be 8 to the half equals 2 to the 1 times 16 to the x plus 1. Bless you. I'm just going to do it down here because I don't have a lot of room. It's the exact same thing as up there. What base can I make them all be? 8, 2, and 16. 2. 8 is 2 cubed. 2 to the 1. 16 is 2 to the 4. To the x plus 1. So I get 2 to the 3 halves equals 2 to the 1 times 2 to the 4x plus 4. 2 to the 3 halves equals 2 to the 1 plus 4x plus 4 because we add exponents when you have same base. 2 to the 3 over 2 equals 2 to the 4x plus 5. And then we set our exponents equal to each other. That's a 5. It doesn't look like one, but it is. So I get 3 over 2 equals 4x plus 5. Subtract my 5. When I subtract 5, I need to get a common denominator, right? So I'm going to make this times this by 2 over 2. This over 1. I'm going to get negative 10 over 2 plus 3 over 2 equals 4x. Negative 10 over 2 plus 3 over 2 is negative 7 over 2 divided by 4 equals x. Let's get my 4 by itself, right? Divide by 4, you multiply by a quarter. Now I'm going to check it with my calculator. So the original was, I'm pretty sure, it was root 8 equals 2 times 16 to the x plus 1, correct? y1, y2. I have one variable. Whenever I have one variable and I'm solving with an equal sign, I can y1, y2. Now, why am I scared to show you this? Because there are people who never learn the algebra way and they're like, I will y1, y2 everything and it will work for life. And then I give you algebra questions and you bomb the test miserably. And I'm like, oh. Because the diploma people are smarter than you think. And they will do questions that involve you actually having to do it algebraically, right? So this is a good checking way. This is a good way to learn because they might actually ask you the calculator method too, right? But it's not the only way, so don't just stick to it, okay? So root 8 is my y1. My y2 is 2 times bracket 16 to the, if your exponent pops up, you don't have to put the x plus 1 in brackets. If your exponent doesn't pop up and it's like mine, you have to put in brackets, x plus 1. Graph. You're going to try and find out where they intersect. You always do. If you can't see the intersection, you can't get the intersection, okay? We can, so that's good. Second, trace, 5, enter, enter, enter. So that's my answer, right? If I go out of my screen and I go X, enter, I can go math. It's the same. Or I can go negative 7 divided by 8. My answer, and it's the same, right? So you can do that always. So for now, if we're given ones like on the next page, which we're going to look at, this one here, if we're given ones like this, 3x equals 6, no matter how hard you try, you're not getting a common base. I know people will say, well, 6 is 3 times 2. It doesn't work. It has to be something to the power of, right? So if this is 3x equals 9, we could make a common base. Because it's 3x equals 6, we can't. So what we would do is we'd go 3 to the x equals 6. We'd go y1, y2. Find out where they intersect. Or, that's method 1. Or we could move it over, 3 to the x minus 6 equals 0, and find the x-intercepts, right? because your y2 would be 0. So that would be you're finding the x-intercept. If ever you can get an equation equal to 0, you're finding the x-intercept. Okay? So 3 to the x, 6. Second trace 5, enter, enter, enter. So for this one, I get 1.63, right? Now I can try it the other way. 3 to the x. Now, this is why brackets is important. Minus 6. How does your calculator read that? 3 to the x minus 6, right? It reads it how it actually is on here. But there's people who have this on a test, and they don't put this in brackets, right? So it's going to read it like this. Is that what you're intending for it to write? No. So if it is like this, you actually have to have that in brackets. Because if I type it like this, this is 3 to the x minus 6, like we're trying to type. Some people are very paranoid and scared they're going to type it in wrong. I'm one of those people. So in high school, I would have done this. 3 to the x minus 6. I would have been like, I'm making sure this is 3 to the x, and I do not care. And then 0. Now I'm trying to find the x-intercept, right? So I can either do second trace 0 and find the x-intercept, or I can go second trace 5 because I put 0 in as the other line. 1.63. Either way got me the same answer. Okay? On the next page is your homework. So that's the homework.